Could hydrogen be the lifesaver for Japan's energy transition? How is hydrogen and the fuel cell formulated into Japan's decarbonization strategy? What road and roadblocks as we look ahead into 2030 and 2050? Bearing these questions in mind, today we are more than honored to speak with Mr. Eiji Ohira, Director General of the Fuel Cell and Hydrogen Technology Office of NEDO, Japan. Ohira-san, on behalf of Leader Associates Impact, I welcome you here. So before we get the presentation started, may I firstly invite you to say hi to the audience and briefly introduce yourself, your role, and how that relates to the Japan hydrogen and fuel cell development.
Thank you, Mori, for your kind introduction. My name is Eiji Ohira. I'm the director for the hydrogen fuel cell office and of NEDO. NEDO is a kind of funding agency under the Ministry and Trade, Economy, Trade and Industry. And we are promoting the several national R&D program. And the hydrogen is just a part of, but a very promising area which we and NEDO are working for. And we have a long history and to working for the hydrogen fuel cell from the since in 1980 and when we were established. But recently, as I mentioned, that hydrogen fuel cell, most of it, one of the very promising technology that we are strongly working for. I'm very happy to join this conference, the webinar to provide and several information.
Thank you so much, Ohira-san. You're absolutely right that NEDO is working closely with the government goal setting and the pilot project development. Hence, your insights into the market are very much needed for the industry to understand the current focus and the future. So now, if I may, I'd like to turn the floor to you and have you formally start your presentation.
Thank you. I hope I can.
Yes.
All right, and thank you very much. And then I mentioned that today I would like to share the kind of information how we Japan and promote hydrogen. Well, let me start at the current situation, the background, and with our activities. And this is Japan current energy situation for the primary energies on the your left side. And recently, our renewables increasing every year and currently reach the 10% of the total energy sources, total primary energy sources, and 20% in the total.
Hello, Ohira-san. I think I lost your voice.
We need to improve, increasing the renewables. But on the other hand, you may see our current carbon dioxide emission from the energy sectors. Energy transition, including the power sector, showed a huge part of the carbon dioxide emission. To tackling carbon neutral or zero emission. We are sort of working for the promoting the decarbonization, the other sector like industry, transportation, the commercial, residential, and so and hydrogen is sort of the part of is a very important part of our challenges for improving the self-sufficiency rate and tackling the climate change issues. And I would say that Japan policy update and at the late Japan also declared that our energy and environment target, which is net zero carbon neutrality by 2050. And to achieve our goal, Japan, mainly the METI, have provided several policy measures. One of the big events is to funding and maybe formulate green growth strategy as well as achieving a national strategy and establishing a green innovation fund. It's approximately 19 billion US dollar to accelerate in several technology for carbon neutrality, including the large scale on the hydrogen transportation, hydrogen power generation, renewable hydrogen, maritime and aviation, steel production. And also, I'd like to mention that Japan's energy policy for 2030. Japan unveiled a new energy mix in 2030. It's increasing the renewable, still keeping the nuclear. That I will say that its new one is put hydrogen, ammonia at the position in a 2030 energy mix. It's the first time. It means that Japan's government recognized the hydrogen. It would be the one of the energy option and with reality, right? This is the kind of an image and how we Japan achieve the carbon neutrality, well, and promote utilization of the electric power in non-electric power like transportation and the thermal energies and etc. etc. It means to convert from the thermal energy to the electricity. And also we put zero carbon power as combination the renewable nuclear fossil fuel plus CCUS and also the hydrogen and ammonia. In the area, still electrification is quite difficult, and hydrogen and ammonia and the biomass are used directly. And the specific action and the target value will be considered in the future. That shows this kind of image how we achieve carbon neutrality. And this is the direction how we have promote hydrogen. Our challenge is to reducing the cost of the hydrogen and to $3 per kilogram to starting at $2 less than the $2 kilogram per by 2050. That is the many hydrogen costs, but this cost is hydrogen and at port. I mean, we plan to import the hydrogen. That the cost of the to that transportation, the hydrogen production in the other countries. And the 2030 is a very important year for us. It's kind of the turning point for Japan, for the hydrogen society. Well, we like to import, start import hydrogen and from the 2030. And we started hydrogen power generation, hydrogen gas turbine power generation starting in 2030. We started the domestic renewable hydrogen in the 2030. It's a very important year. Toward the 2030, we're working so for very hard for developing the technologies, developing the social on the systems, a system including the regulation code and the standard or any policy measure. Right, let me talk about the current status of the hydrogen fuel application. And our first commercial application is a stationary fuel cell, residential fuel cell, namely NEDO. And it's launched almost 10 years ago, 29. Now we have over the 400,000 units around Japan. In the mobility sector, we have already in 7,000 passenger vehicle, mainly Toyota Mirai, and fuel cell dominant in buses running and mainly in the Tokyo city area regularly, and its number of the buses over 100. And the public station, hydrogen filling station, that is the key for the dissemination of the mobility, fuel cell mobility. Now we now 160 hydrogen filling station in operation. And the next, let me talk about NEDO's activities. And, as I mentioned earlier, and we organized several national and project, including the hydrogen fuel cells. Well, we take and we're working for the hydrogen to production and storage and transport and utilization for the basic research, applied research, and demonstration, etc. And now there's the hydrogen and the fuel cell technology and the hydrogen production, etc. Right, and this should show kind of our strategy, step-by-step approaches. I know first right now we're working for to commercialize the residential fuel cell, and this is kind of bring the fuel cell application into the general market. You know, as I mentioned, that it succeed commercialization in 29. And the next step 2 is realizing the fuel cell vehicle and the hydrogen filling station. Yeah, and the fuel cell vehicle provide a good environment and option. But the most important thing is this application, through this application, is a direct use of the hydrogen as energy sources in the society. We need to develop, not only a technology, but also the kind of social system. I mentioned that regulation code standard, etc. Will they succeed at commercialization in 2024, as you know? And the next step is how to develop, how to expand the hydrogen demand. I mean that we may use hydrogen in energy system. That's the key, currently key. Let me talk about the snapshot or recent project. And this figure shows our working for our efforts for hydrogen gas turbine. We may use the hydrogen and instead of the liquefied natural gas for the power generation. So we're working with small size and hydrogen gas turbine and large scale or hydrogen and natural gas. Well, we try to expand the size of the hydrogen gas turbine, and as I mentioned, that to realize it in 2030. Okay, and Japan need to import and hydrogen in the future. But the challenge is how to concentrate and hydrogen for long distance and transportation. And one of the choice is liquefied the hydrogen. We already have developed a small, but the world's first hydrogen and tanker, and also the to some of the liquefied hydrogen the handling equipment at port. We are still continue to working for the demonstration, and we are investing a huge amount of money to scaling up this liquefied hydrogen or any other hydrogen carrier international transportation. And also power to gas is quite important for to realizing kind of green-based energy systems. There are key technologies and to electrolysis. And we Japan are conducting the megawatt scale on the power to gas in the 2 areas. And one is in Fukushima Prefecture in the very northern part of Japan. It's based on the Asahi Kasei megawatt alkaline water electrolysis. And the other one is to Yamanashi Prefecture, the center of Japan, with 1.5 to 2 megawatt PEM water electrolysis developed by the Hitachi Zosen Corporation, and to using the tolate and the hydrocarbon membrane with the high efficient to membrane technologies. Well, we know start to continue the demonstration, and the next step is scaling up and to through the 100 megawatt plus in several years. And lastly, and let me talk about our demonstration project and at port. Well, we try to develop localized and hydrogen and utilization model. This figure is an overview of our current effort at the port in Los Angeles, California. And, from the viewpoint of the air pollution control, electrification at port equipment, it became an important issue. Well, and battery is an option, and hydrogen is a very to most to promising option. Decarbonization or electrification at port. We try to develop the several fuel cell applications like a top 100 to country grain, and the truck, the EH truck, and the install and the testing the usability at port. So, and let me conclude my presentation. And hydrogen is not a single solution, but a key technology for the carbon neutrality. Where Japan has become strongly promoting hydrogen, and we are working for the hard, but still continue to expand in our effort. We just start market penetration on the hydrogen fuels application, but we need to expand our application, also improving the technology itself. But our goal is not only to disseminate in the fuels application, but also developing the low carbon energy system. We're working on the several approaches, but the key work is in scaling up for integration with other energy systems. Well, with Japan, again, Japan is working on the hydrogen very hard, and also to including collaboration in other countries. Thank you very much for your attention.
Thank you so much, Ohira-san, for the very informative and thought-provoking presentation. I think the industry is inspired by NEDO's efforts and is looking forward to collaboration with your side. In the meantime, we have also received several questions from the audience to you. If I may, can we accommodate 2 or 3 questions here? Yes, the first one goes to the market comparison. So from your perspective, is there a different focus for the hydrogen economy in Japan compared with that in the European Union? Or more specifically, compared with the strategy in Germany, in France, or in the UK as an island nation?
Okay, I think that's quite a very important question. And as I mentioned that, and the hydrogen market has not developed yet. So not it's not and well talk about the details. And but we are all over the world and working for developing hydrogen in the market. But the approach is a little bit different, especially and developing the first demand. As I mentioned in my presentation, Japan tried to develop the hydrogen demand and through the hydrogen gas turbine, hydrogen power generation, cooperate with to power company in Japan. But in my understanding in Europe and working collaborate with the industries, hydrogen utilized in chemical and steel production and at the refinery also. Both approaches in the future is quite important in the future, but the starting approach, early stage approach is a little bit different. Yes, in my view.
Thank you. I think you just mentioned the challenges, the constraints we see in this industry. And the next questions, again, is about the constraints. So when we talk about the lack of demand, the lack of balance between the demand and supply, the lack of commercial viability. So what are NEDO's response to address these challenges?
Well, it's quite important, quite difficult challenges, you know. We recognize that there is a quite early stages, and again, that the hydrogen and fuel cell market has not developed. In this case, in the issue is how to how to involve the industry in this field, and this is quite a governmental leadership. It's quite very important, and government leadership is mainly the message how which Japan transform, how the world in a transform for the future. As I mentioned, to understand that energy transition needs quite long term, to 10 years and 20 years. But a strong message is quite important. A strong message, and we do that. We may invest in this area, well, etc., etc. Not a single country, and then multiple countries also. And we are collaborate with the Japanese government to provide the Japan message, to show the huge amount of the money for the R&D area. You know, we also to collaborate with other countries to develop the momentum to promote the hydrogen. So through this activity, we have believed we can to involve any industry around the world to realize in the hydrogen-based market, hydrogen-based society and the hydrogen market.
Yes, and narrowing down to the hydrogen in Japan's transport sector. So how much demand do you foresee hydrogen in the Japanese transport market, including the mobility market, the heavy-duty market, etc.? And what are the immediate opportunities you see, and what are the opportunities you see in the medium and long-term scenario?
Yes, I didn't have any concrete scenario of how we change, transform to get the combustion-based transportation to the electrification-based transportation. But now we are now developed at a very early stage. Yes, we Japan launched the commercial, passenger vehicle, and also several years ago, but still very early stage. We need some experiences. It's kind of demonstration. Okay. And through the 2030, as I mentioned, the 2030 is quite important, and we expanded the passenger vehicle, not only passenger vehicle. And from this year, we are working for the demonstration for commercial vehicle, truck, small, medium, heavy-duty trucks, and also we try to expand in the high fuel cell buses. And so combination with the passenger vehicle and commercial vehicle. We are still keeping the continue to working for the expanding this and the fuel cell vehicle. But remember that and to battery electric vehicle and the fuel cell vehicle, we not compete. Both of the technology is just electrification of the to transportation, and the customer may choose and based on their needs. And we must not provide which is better, and the customer may choose battery and fuel cell.
Thank you. And also, the hot wave of hydrogen is because it's linked with energy independence, energy security of a nation. But for Japan, imported hydrogen, imported alternative fuels are still imported fuels. So there's also a conversation domestically regarding the imported hydrogen and alternative fuels versus locally produced hydrogen and alternative fuels. For example, using offshore wind plus hydrogen, or using nuclear to produce hydrogen. So what does NEDO perceive the trend, I should say?
Well, we are not in the R&D for promoting organization. We can talk about in the Japan energy policy, but in the personal opinion, yes, and Japan try to expand our renewable, not only the PV, but including the offshore wind, very promising energy sources in the future. But it's very difficult to cover all of the Japan energy demand because Japan energy concentrated country. And to merit of the hydrogen can be produced the several many from the many resources and from the coal oil to natural gas and renewable, etc., etc. So and we have the chance to develop the new resource countries and from the I mean the kind of political stable, including political stable company, countries, whatever. And energy security is very important, and we also to secure the energy security, we find in the new energy continuing the new countries to collaborate in this field and for the stable securing the stable energy. But also to try to expand in Japan's energy self-sufficiency rate, we still have the very small, the 10% and around the 10%. But we try to expand it to 20%, 30%, 40%. But still, we must second import the energy sources or to good relationship. It's quite very important for us. There's a combination.
Right, the mix, the diversity.
Right, yes.
So one last question to wrap up the Q&A session. So it's regarding the energy carriers. In the last slide, you mentioned that NEDO is doing some initiatives for hydrogen at ports. And actually 2 weeks ago, we conduct an interview with the port authority from Singapore, from Japan, to understand their concerns at the moment. So they told me that their concern is the lack of focus on the technology choices. If they want to invest for the infrastructure, they need to understand what kind of carriers will be.
Well, and it also need
market.
Sorry. And this maybe to the energy carrier question, it's quite related to and color of the hydrogen question. But we also asked which color and color of the hydrogen Japan to promoting the blue, gray, and green, etc. Sorry, not gray, blue and green, etc. Which is better. And I would say that if we import hydrogen, and the point is and the cost of the hydrogen, and also the carbon intensity of the hydrogen. We not care. It's not concerned about the color of hydrogen, and also we are concerned of the energy carrier, hydrogen carrier with the liquefied hydrogen and organic chemical hydrates, etc. Our job, our role is providing the technological option and for liquefied hydrogen and organic chemical hydrate, and industry and may choose to based on their philosophy or their resources. Right? And if they have their very close to the chemical resources, they have the chemical resources or the oil relevant resources, may choose the organic chemical hydrates because it's very familiar to their business. If they are working for the to liquefy the hydrogen, and they may choose the liquefied hydrogen because they may use their asset, including the human resources, and so. I cannot say, I must not say that which is better and of the energy carrier of the color of hydrogen, but it's based on decision of the industry. So it's not direct answer to you.
Understood. Let the market decide for itself. Right. So thank you so much, Ohira-san, for your kind and generous sharing. As much as I'd love to have you talk forever, I must let you go for the upcoming meetings. Again, I thank you for joining here. I really enjoyed talk, and I hope you enjoy the same way I do.
Thank you very much. I look forward to enjoying it.
Thank you so much.